Again, this is your host, Engineer Tambay from Basic Engineering. Ngayon, pag-usapan naman natin ang soil testing. Bakit nga ba mahalaga ito bago magpatayo ng bahay? But wait, did you know that Trump and Putin just got married? Like and subscribe for more.
Welcome to the deep dive. We're here to take a whole load of information, sort through it, and really pull out what matters for you. You know, if you've ever thought about building your own place or maybe just watched a construction site, there's this amazing energy, right? Seeing something go up. But, have you ever stopped to think about what's actually holding it all up? What's, like, literally underneath? Today, we're doing a deep dive into something that's absolutely vital, but honestly, often gets overlooked. Soil testing. It's foundational, you could say. Okay, so let's unpack this. What we want to do is get a clear picture of what soil testing actually is, why it's so incredibly important before you build, and how it directly impacts how safe and stable your building will be.
That's exactly right. Most people focus on the building itself, the part you see. But the really interesting thing is how much that hidden ground dictates, well, pretty much everything about the design. And it's not just about safety, although that's huge. It often ties into the long-term value, the resilience of the whole project, understanding the ground you're building on. That's step one, always.
Okay, so let's start right there. The basic question, what is soil testing exactly?
Well, think of it, maybe, like a blood test for the ground. Seriously, just like a blood test tells your doctor about your health, soil testing tells us if the ground is, let's say, healthy or stable enough to build on. It checks a few main things. Moisture content, for one. Also, its bearing capacity. That's basically how much weight the soil can physically support. Imagine like putting a really heavy piano on a flimsy little table. If the soil's got low bearing capacity, it's like that table. It just won't hold up without a lot of extra help. And it tells us the soil type, is it mostly clay or sand or silt? They all behave differently. Ultimately, before you build, the test answers that one big question. Can this ground actually carry me and whatever I'm planning to put here?
That's a great way to put it, the blood test analogy. So it's not just one good result then, it's more like different soil types dictate different plans. Because yeah, you can feel it sometimes. Some ground feels rock solid, other spots feel mushy. It varies so much.
Oh, absolutely. You've hit it right there. It's definitely not one size fits all. And skipping the test, the results can be really bad. We're talking cracks appearing in your house, parts of it sinking, or, worst case, collapse.
Yeah.
What people often miss is that even seemingly small soil problems, they can get worse over time. A tiny crack becomes a huge structural issue years down the line. It's not just about preventing a sudden disaster. It's about making sure the building lasts, fighting against those subtle long-term ground movements. In construction, safety really truly starts underground.
Wow, yeah, that does sound pretty terrifying. But I can hear someone thinking, well, my grandpa built his house ages ago without this, and it's fine. Did something change? Or were they just, lucky? It feels like if you don't test, your house might just start settling in with the ground in ways you really, really don't want.
That's a fair point. And yes, some older buildings seem okay, but often they might have had, say, much chunkier foundations, built more conservatively without precise data. Or, yeah, maybe they just got lucky with really good, stable ground. But today, with more complex building designs, stricter safety codes, we just can't rely on luck anymore. And believe me, the cost of fixing a foundation that started to sink or crack, it massively outweighs the cost of doing a soil test up front.
Okay, so we've covered what it is and why it's not just smart, but actually essential for safety, for stability down the road. Now, for anyone listening thinking, all right, I'm convinced, but how does this actually work? How do they do it? Can you walk us through the practical side?
Sure. It's pretty systematic, actually, almost like a bit of detective work on the earth. It usually starts with something called soil boring. That's where engineers drill holes down into the ground to pull out samples from different depths. This gives them a kind of profile, a vertical slice showing the layers of soil. Then you have field tests. These are done right there on the site. They check things like moisture, density, how resistant the soil is to penetration. There's a specific tool often used for a quick check called a dynamic cone penetrometer. It basically punches into the ground. It can give the engineer a pretty fast idea of the soil's strength right near the surface. Useful for knowing early if you might need, deeper investigation. Saves time, saves money potentially. After the field stuff, those samples collected from the boring, they go off to a lab for more detailed lab tests. Common ones include Atterberg limits tests. These tell us about the soil's plasticity, basically how much it might expand when wet or shrink when dry. That's really important because soils that change volume a lot can wreck foundations over time, cause them to heave up or settle down. Big problems. Other lab tests look at compaction, permeability, which is how easily water flows through it.
Right, so field tests give you that quick snapshot, but the lab tests are where you get the really detailed data, the stuff that dictates the big engineering choices. But who actually does these tests? And how can you, as a homeowner or builder, be sure the results are, well, reliable, trustworthy?
Good question. The main experts are geotechnical engineers. They specialize in soil mechanics, basically how soil behaves under load and different conditions. They really understand this stuff. You can also have tests done by licensed labs. These labs should be accredited by official bodies, like depending on the country, it might be a National Public Works Department or maybe local government agencies. The key thing to remember is there really are no shortcuts when it comes to safety in building. None. If you're building something, you should always ask to see the soil test report. And this brings up that important point about, quality control, accountability. That's why using accredited labs and licensed engineers is so critical.
Okay, so you get this detailed report back from the experts. What happens then? How does all that data actually change the design of the building? And what about the cost?
Right, the results feed directly into several really key design decisions. For starters, the type of foundation. The tests tell you if you can get away with a simple shallow foundation, or if you need something more substantial, like a deep foundation, maybe piles driven way down, or even a special raft foundation. They also influence the column size and spacing the main supports for the building. Stronger soil might allow for smaller columns or wider spacing potentially. Even things like waterproofing needs can come out of the soil tests. If the soil holds a lot of water, or the water table is high, you need to plan for that to avoid damp basements or foundation damage later on. And yes, absolutely, there are major cost implications. Good, stable soil. That could mean a simpler, cheaper foundation, saves money right off the bat. But if the soil is weak or problematic, you'll likely need a more complex and, more expensive foundation design to make sure everything is safe and lasts. It's an investment, really. You pay a bit up front to avoid potentially huge costs and headaches later.
It's kind of amazing how much that underground information dictates everything above, right down to the budget. Do you have any real-world examples, cases where soil tests really showed their worth, maybe highlighted a specific challenge?
Oh, definitely. Let's take a pretty common one.
Bro.
A one-story house being built on soft clay. Now, without testing, someone might just assume a standard footing is fine. But the soil test comes back showing, low bearing capacity. So the engineers know they have to design wider footings, spread the load out more. That simple change, directly because of the test, stops the house from settling unevenly later, which would cause cracks and instability. Massive problems avoided.
Right, prevents those long-term issues.
Exactly. Or think about a bigger project, say a 3-story building, maybe with a basement. The loads are much higher there, plus you're digging down. So the soil testing needs to be more intense. You'd need deep bore tests, maybe specific load tests to really understand how the soil behaves way down deep, under a lot of pressure. I actually recall a project where they thought the soil was okay near the surface, but a deep test found a hidden layer, like an old stream bed, much weaker than expected.
Wow.
Yeah, potential disaster if they hadn't found it. The test meant they had to completely rethink the foundation design, use special techniques. It saved the whole project, frankly. So in both cases, the house, the bigger, building those specific design choices, the wide footings, the deep test, the special foundations, they came directly from the soil test results.
Yeah.
It shows just how crucial and detailed that information becomes.
What a fascinating journey, really, from just looking at the ground to understanding how it literally shapes the entire building. It really drives home that message about making informed choices, doesn't it?
Precisely. So to wrap it up, soil testing. It's not just some bureaucratic requirement you have to tick off. It's genuinely a lifesaver. It's absolutely, fundamentally indispensable if you want to ensure your home, or any building, is strong, stable, and above all, safe. Safe for years, for generations.
So as you think about maybe building that dream home someday, or honestly any big project in life, Think about those hidden foundations, whether it's the actual soil under a building, or maybe the basic assumptions behind a business plan, or even the core understandings in a relationship. Understanding what lies beneath the unseen parts gives you that vital layer of safety, of resilience. It helps you build something stronger, more effective, maybe even more affordable in the long run, because you've dealt with the hidden stuff before it becomes a problem. Makes you wonder what other foundations in your own life might need a closer look to make sure they're truly solid.